Fun fact, the moon is slowly moving away from the Earth. During the Apollo missions, NASA placed retroreflectors on the surface of the moon, and that meant that scientists could point a laser at the moon and measure the time it takes to reach the moon and come back. Using this and knowing the speed of light, they could calculate how far away the moon was. And this technology is very, very accurate. So accurate that they were able to detect that the moon is moving away from the Earth about 3.8 centimeters per year. Now, this may seem like a small amount, and it is, but over a large period of time, it adds up. So eventually, it'll have very serious consequences and effects here on Earth. Of course, things like the tides might change, but also climate patterns, Earth's tilt and axis, and even eclipses will change. In fact, also the length of a day will change too. Hundreds of millions of years ago, Earth's day was only about 18 hours long, rather than the 24 hours that we know today. So hundreds of millions of years in the future, maybe a day on Earth will be 30 hours long, or even longer. But why does the moon move away? This process is called tidal acceleration, and it's because the moon causes tides. The moon's gravity pulls on the Earth and pulls on the water on Earth, creating these tidal bulges. Here is an image of these tidal bulges. The water gets pulled towards the moon, and also Earth's rotation causes some inertia, so there's bulges on both sides. This is the tidal bulge. Now, what this diagram is missing for the tidal acceleration is the fact that Earth's rotation is faster than the moon's orbit. So the tidal bulge gets pulled ahead in front of the moon. This is called the tidal bulge offset. This tidal bulge offset is going to cause the water to pull on the moon and kind of slingshot it into a farther orbit, which causes it to slowly move away from Earth. Isn't that interesting? Isn't that fun?